Welcome to Pre-Cal Trig. We're still on Unit 1. We'll be covering Lesson 3, Dividing Polynomials today. Now, after you've gone through and completed your quiz for Lesson 3, you need to go on to Lesson 5 on your own in the course content. So let's start by watching this video. We're going to do a quick review of how to find the degree, the leading coefficient, and the constant value in a polynomial. So we'll start with this polynomial, f of x equals 11x to the fifth plus 7x to the third plus 5x plus 4. This polynomial is in standard form. What that means is we start with the highest degree, so we'll go ahead and circle that. We have a x to the fifth, and then we go back in descending order, or go down in descending order. X to the third. This is x to the first power. We don't normally write the 1, and this is x to the 0 power. X to the 0, remember, is 1. And so 1 times this number will give us our constant. So we write the degree by taking the highest power. So the degree of this polynomial is 5. And then in standard form, it's easy to pick the constant. Constant is going to be 4. All right, now let's move on to our second example. We have a polynomial, g of x is equal to x plus 2 times x minus 1 times 3x plus 2. So we have 3 binomials that we're multiplying together. You could multiply those out using the box method, or you can just use this shortcut. X times x is x squared, and then x squared times 3x is 3x to the third. That will give us our leading coefficient, which is 3, and it also gives us the degree of our polynomial. So you don't have to multiply this all the way out to get the degree or the leading coefficient. Now we're also going to do something similar to find our constant. Now remember that the constant is going to be our y-intercept. So there are a couple of things you could do. You could use Desmos if you had access to a graphing calculator, and any kind of calculator that would show you a graph of where it crosses the y-axis. So that would be your constant. Now in this case we don't have that right now, so we're going to do something similar to what we did before. We're going to take that 2 times negative 1, 2 times negative 1 times 2. So that's negative 2 times positive 2 is a negative 4. So our constant is going to be a negative 4. We just multiply those together. Now if you're looking at the I can, if you don't know what that is, I would come into a help lab and then ask for me to show you, or get into our course and look at the resources. The I can does have a calculator that will do this multiplying for you and put it in standard form. So we all know that we should be studying our vocabulary prior to coming to class. So we'll start with this warm-up. Join us at nearpod.com, join.nearpod.com. This was a live session in class, so if we're watching this after class, we're going to put in the code T as in Tom, K as in kangaroo, the number 8, C as in cat, N as in Nancy, and then join. And then you're going to complete this on your own. Again, remember, grab your name from Office 365. Log in with your Texas Online Prep account, verify your name, and say continue. So it'll put your name in. No more of these made-up names. I know who you are, so let's stop doing that. And then choose your character. So choose something. So go ahead and move through that, get that done, and then we'll go back into the lesson. Our spotlight this week is going to be on Unit 1, Lesson 3. This is about dividing polynomials. We're going to be using long division, just like you learned with numbers in the 4th grade or so. And then we're going to be dividing using synthetic division. This may be new to you. So anytime something is new, it's going to require a little bit of practice. So make sure you're getting into the course, into the content, practicing and taking notes. We're going to be applying the remainder theorem, applying the factor theorem, and these are theorems that you can find in Quizlet. Remember to review the vocabulary that I add in weekly prior to coming to class. And you can keep that open while we're working through these lessons. It's helpful. If you're not connected to Quizlet, let me know, or come in during office hours or help sessions, and I'll help you get connected to that. And then we're going to be using synthetic substitution as another way of looking at the remainder theorem. To start with the fundamental theorem of algebra. If you reviewed the vocabulary, you've read this, maybe you don't quite understand what it means, but we are going to talk about it and break it down. If we have a polynomial function, f of x, and it's to the degree of n. So for example, I've given you this example down here. We have a function in standard form with the highest power to the left, and then it goes down in descending order. So it starts with x to the 3rd power, that's the highest power, and then x squared. We have no x to the 1st, but we have a constant. All right, so that highest power is going to be the degree of our function. So n in this case is 3. So it has, this function has exactly 3 zeros. We've already talked about that. Or roots. Another way to say that is solutions. Again, we can say where it crosses the x-axis. So x would equal to whatever this value is here. It looks like 1, 2, 3, 4, 5, negative 3/5. We have another root here at positive 1 and another root here, or zeros. We can also have a multiplicity. Remember what that means is we could have 2 roots. If it hits negative 1 and bounces up in the opposite direction, it just means we have 2 of these. X plus 1, we have 2 of those. That's where it would hit and bounce up. Okay. All right, so it has exactly n zeros. So if we have a polynomial of degree, let's say it's 3x to the 5th, this is the highest power, we would have 5 roots, or 5 solutions, or 5 zeros, or 5 places it crosses the x-axis. Now, how do you determine if x plus 4 is a factor of f of x equals negative x to the 4th minus 6x cubed plus 15x minus 72? Well, we use the factor theorem, and we evaluate the function for x equals negative 4. So how in the world did I get x equals negative 4? Let's take a look at that. We start with this factor, and we're going to test to see if this is actually a factor. So when we factor a polynomial, we might have something like x plus 3 times x plus 4, and so on, several binomials equal to 0. So if we take each of these and set them equal to 0, we have a solution. Because if this part is equal to 0, 0 times anything is 0. So we have a true statement. So if we set x plus 4 equal to 0, and we subtract 4 from both sides, we get x is equal to negative 4. That's where that x equals negative 4 came in. We're going to take that negative 4 and we're going to substitute it into this function everywhere there's an x. So we start off with negative 4 to the 4th power minus 6 times x, and I'm going to put negative 4 to the 3rd power. Should be putting that inside there. Plus 15 times negative 4 minus 72. All right, get your calculator out. I think you can do this with just a simple calculator. So we'll take negative 4. Struggling with getting my pen to show up. Here it goes. Take that negative 4 and raise it to the 4th power. So if we have an even number of negatives, we're going to get a positive answer. So negative 4 to the 4th power is 256. That's what's inside the parentheses. All right, you still have a negative outside that you need to multiply to that positive 256. So we get negative 256 when we simplify this part. Now let's move on. We're going to subtract 6 times negative 4 to the 3rd power. Now this time we have 3 negatives. So this answer is going to be negative. And then 4 to the 3rd power, 4 times 4 times 4 is 64. So this is 6 times 64. I'm sorry, negative 6. Don't forget, those negatives will mess us up if we don't go slow. Negative 6 times negative 64 gives us a positive 384. And always check my work, especially if I'm at the board, to make sure that I am multiplying correctly. All right, negative 4 times positive 15 is negative 60. A negative times a positive. Just can't get my pen to show up here. Hold on. Let me move my mouse around. Okay, there it is negative 60 minus 72. So I'm going to get my calculator out. I'm going to add all those numbers together. And let's see what we get. Negative 256 minus 384 minus 60 minus 72. I don't even know if I did that right. I got negative 772. So let me check these signs again. We have 4 negatives. That's going to give us a positive. And then we have a negative on the outside. Okay, so that gives us negative 256. And then we have a negative times negative 4 cubed. This is where I made the mistake. This is going to be positive. So those signs are tricky. I don't write real neatly with my mouse, but here we go. Negative 6 times negative 64 is a positive 384. And then 15 times negative 4 is negative 60. And then negative 72 was already given. So let's add those up together. All right, so I've got negative 256 plus 384 minus 60 minus 72 is equal to, I got negative 4, but I didn't get 0. So check my work. If you don't get 0, this is not a factor. If you do get 0, then it is a factor. All right, so this time I'm going to let you try and see whether x minus 2 is a factor. So you'll start off by setting this equal to 0. Add 2 to both sides and you'll get x equals 2. So take that 2 and substitute it in everywhere you have an x in your polynomial. If you get 0, it is a factor. If you get anything other than 0, and I would double check this, it's not a factor. All right, so you might want to stop right now. I'll pause for a few seconds, but pause your video and see if you can work this out yourself. All right, let's go ahead and work this together. Okay, in this case, we have a positive number, so it's going to be a little easier for us. We have 2 to the 5th power. We're going to multiply that times 6, and then 22 times 2 squared plus 11 times 2 minus 126. All right, 2 to the 5th power. 2 to the 5th power is 32. We're going to multiply that times 6. Okay, 6 times 32, let's go ahead and do that, is 192. So we simplified that. All right, minus 22 times 2 squared. 2 squared is 4, and 22 times 4 is 88. Plus 11 times 2 is 22, minus 126. All right, now take these numbers and let's combine them and see what we get. All right, 192 minus 88 plus 22 minus 126 is equal to 0. So yes, x minus 2 is a factor. All right, now we're going to go into dividing polynomials using long division. So this is just, we use the exact steps for dividing like when we learned how to divide whole numbers or real numbers. So the first step is to set this up like you would divide a whole number or a real number. Step number 1. And then determine how many times the divisor goes into the leading term of the divisor, or how many times x goes into the leading term of the dividend. For example, let's say that we are dividing 2 into 115. So we would take that 2 and see how many times that 2 goes into this leading term. Okay, it does not go in, so we have to move over and take these first 2 terms and say how many times 2 goes into 11. It would go in 5 times and we put it up here. So we're following those same steps, and we'll demonstrate that in a minute. Okay, then we multiply and write the result under the dividend. So we would multiply these 2 numbers together and put it under the dividend. The dividend is what's underneath that division symbol. Okay, and then step number 4, we subtract and we bring it down, being careful to subtract every term. So 1 minus 0 is 1, and 1 minus 1 is 0. And then we bring down the next term, and we continue. And then when we're at the end, we include the remainder in our answer, and then we check our work. All right, so copy those steps down, and then we're going to work through 1 or 2 of these together. All right, so we have a polynomial on the top. We're going to make that our dividend. So we're going to put that underneath the division symbol. 9x to the 4th minus 12x cubed plus 10 divided by 3x to the 3rd plus 2. Now, the key is to go slowly, carefully, check your work, because there's so many places you can make mistakes. So that's why it's important that you do the teacher graded assignments, because I will check your work and you get much more credit for showing your work, because it's so easy to make mistakes and trip up, especially if you're going in a hurry. The quizzes are short. You shouldn't have to hurry through them. All right, so 3 goes into 9 3 times. And then x to the 3rd needs to be multiplied by another x to the 1st power in order to get x to the 4th. But if I look here, there's something I want to point out because it's a big mistake that we always make. I jump from x to the fourth to x to the third and then to our constant. I'm missing an x squared term, so I have 0 of those. And I'm missing an x to the first power term, and I have 0 of those. So I have to fill in those numbers, just like if I was dividing 3 into 907. If I just put 3 into 907 and wrote the 907 like this and forgot the zeros, that would be a completely different problem. So let me set this up again. And let me try to save my space here. 3x to the third plus 2. So this is a common mistake that I often make when I'm learning. Let's don't forget to fill in those zeros. So 9x to the fourth minus 12x cubed plus 0x squared plus 0x. I'm getting smaller and smaller. I feel like I'm going to run out of room. Plus 10. Okay. Now we're going to take this first term and we're going to try that again. So 3 times 3x gives us 9x to the fourth. Now look at this number that we got that we're going to need to multiply by that first term by. So we're going to line that up over where the x to the first powers would go. So it goes right here. All right, but just make sure that you're lining up over that term. That kind of gives you an idea of where to stop. All right, go ahead and multiply this, what we just determined we needed, to both terms. 3 times 3 is 9, and then x times x to the third is x to the fourth. And this is going to line up underneath that first term. But make sure that you multiply by that second term. 3x times 2 is 6x. So that's going to go down here. And then everything else is going to be zeros. Okay, now make sure that you subtract every term, not just the first one. Subtract, zeros are neutral. Subtract, bring this down and you get 0. I'm just going to leave that off. And then we get negative 12x to the third when we add or subtract 0 plus 0x squared. And then we'll go ahead and combine these two minus 6x. Don't really need to bring that down yet, but we're almost done. All right, now look at this term. What would you multiply this by? 3x to the third to get negative 12x to the third. That would just be a negative 4. And notice that that's going to line up in this column where the constants are. Okay, so we're going to be done after this step, and then we'll end up with a remainder or not. All right, so take that negative 4 times positive 3, and you get negative 12. Well, I put that 4 there. X to the third. And then multiply that also by the positive 2. Negative 4 times positive 2 is negative 8. Now that goes way over here where we have that constant term that I did not bring down, but I do need to bring it down. And remember, there are zeros here. So I'll just put those zeros in to hold my place. And then change the signs to the opposite so we can subtract. That becomes positive and that becomes positive. So when we combine these two, we get 0 here. We get 0 here. We get negative 6x plus 18. I don't think I'll ever learn how to write with a mouse. All right, so this is our remainder. And this is our multiplicand. This is one of our factors. 3x minus 4 times our divisor here, 3x cubed plus 2. When we multiply those out and we add this remainder, we'll get that dividend that we started with. So our answer is 3x minus 4. Go slow. It takes a little bit of time, but as you practice, you'll get better. You just don't want to rush through these. All right, now let's look at what we've learned so far. The remainder theorem, we're going to put that into play. We have multiple choice, so it's not going to be as hard as it looks. So let's break it down and determine what it is that we're trying to find. All right, Juan determines the remainder of negative 32x to the 9th plus 5x to the 7th minus 3x to the 4th plus 6 divided by x plus 1 using the remainder theorem. How does he proceed to the correct answer? So think about what we did at the very beginning. We're going to take the divisor and we're going to set it equal to 0. Solve for x. X is equal to negative 1. Then we're going to plug that in everywhere there's an x into this equation. So this is going to be negative 32 times negative 1 to the 9th power plus 5 times negative 1 to the 7th power minus 3 times negative 1 to the 4th power plus 6. All right, take a minute. This is going to go a little quicker than the others because we're multiplying by a negative 1. 1's easy to multiply. But we've got to consider what negatives do when we have an odd power. Negative 1 will pair up and leave one extra negative 1. So negative 1 to the 9th power is going to be negative 1. So this is negative 32 times negative 1 is positive 32. Okay, now we're going to move on here. We have another odd power. Negative 1 to the 7th power is going to give us, odd powers give us a negative, even powers give us a positive. So this is going to be negative 1 times positive 5 is negative 5. Okay, now we have an even power. Even powers give us a positive. So this is going to become positive 1 times negative 3, makes it a negative 3, and then plus 6. So let's stop for a minute and consider what we've done so far. Okay, first of all, we started with x equals negative 1. So look at that first answer. Is he evaluating, and I made a mistake right here, it's not numerator, it's numerator. So just another example that where none of us are perfect. All right, so it's not when x equals 1, it's when x equals negative 1. So we can cross that out, cross this out. This would be the only one that would work, but I'm going to go ahead and follow through just to make sure that I did not make any mistakes here in my answer. So it should be, when we substitute that in, we find the remainder of the division to be 30. So what that means is I take my calculator and add those numbers up. 32 minus 5 minus 3 plus 6, I do get 30. So my answer is C. All right, hopefully you're seeing how, again, this pen is so tiny, I lose it. Okay, hopefully you're beginning to see how this all comes together and how important it is to study your vocabulary before we start our lesson. All right, so we have another division problem here. All right, I'm just going to go through this quickly because we already have an answer. So let's just run through what the steps are. We're dividing by this polynomial. So we take that first term and we divide it into the first term here. So it's going to go in 2 times 2 and another x squared. When we multiply this to this term, we get 2x to the third. It should line up right underneath. We have to also remember to multiply it to the second term, and we get 4x squared. Line that up underneath the x squareds. And as you can see in this example, we don't have any places to put zeros because we have x to the third going in descending order, x squared, x to the first. We normally don't write that one. And then this would be an x to the 0. We don't write that either. X to the 0 is 1. All right, so we've multiplied that out. Now we need to subtract both terms. So make sure that you change this to a negative and this to a negative. Now add those together. You should get 0 here. If you get anything other than 0, go back and check your work. -3 plus a -4 is a -7x squared. Bring down the 4x, and then we'll do that all over again. How many times, what do you multiply x by to get x squared? You multiply by to get -7x squared. You multiply by -7x. It's kind of a check when you do this. -7x times x is -7x squared. So that should line up right underneath, be the exact same thing. Don't forget to multiply that second term by -7x, and you get negative times a positive is, this is -14x. There was a mistake right here. It's always good to go back and check your work. So this is -14x. Okay, now we're going to subtract the binomial. So we've got to change both of those terms. This becomes positive and this becomes positive. So that's how we get 0 here and how we get positive 18x here. And then bring down the 5 and then repeat again. Look at that first term. In the first term here, we'd have to multiply x by 18. We put that here. We multiply both terms in that binomial, line everything up. We would have a positive 18x right here. They're skipping steps. And then 18 times 2, 36 here. That's positive also. And this is where you check your work because it looks so nice, but you get to the end. Okay, so this is what we got when we multiplied. We need to subtract. So this becomes negative and this becomes negative. So when we add these two together, we get 0 and we get -31 here. So this is our remainder because we're at the end of the road up here. So this is our answer, and you need to include the remainder. You can either write it with an R, but we typically write it as remainder -31 over x plus 2. That's our remainder. All right, moving on to the next. Now we're going to look at the long division. We're going to convert that into synthetic division. All right, remember we put the coefficients underneath the division symbol. Okay, and we're going to divide by x plus 2. So we take this number and we put it outside the division symbol. Okay, but it's not going to be a positive 2, it's going to be a negative 2, because remember we have to set this up, this binomial equal to 0, and solve for x. So this is going to be x equals -2, and that's where that -2 comes in. These are the steps for synthetic division. Bring down the first term. Okay, so we'll bring down the 2. We'll take this divisor, multiply it to that 2, and get -4. And then we'll put that right underneath here. So we flip this division symbol upside down, but leave enough room for a second row to put some numbers in. All right, so let's look at this again. We get -4, and then we're going to add these two together and get -7. We're going to repeat the process. -2 times -7, put that up here, is positive 14. Add, get 18. Repeat, -2 times positive 18 is -36. Combine those terms together, and you get -31. So we're going to interpret what this means, and that's what this is right here. In this case, oh man, I can't write very well. I have to click on it. All right, in this case, the quotient, or the answer, what we get is going to be 2x squared. So if you notice, we started with x to the third. So we're going to go down to the next descending power, 2x squared. Take that answer that we got, put it in front of x squared, and then minus 7, keep descending, x to the first power, plus 18, x to the 0 power. That's our constant, and that's where we stop. So our remainder would be 31, or negative 31. So that's how we interpret that answer with synthetic division. All right, let's move on to the next slide, and let's see if we can put this together. All right, again, we're just going to go over how do we write the answer, that last problem that we did. So if this were our original polynomial, and we're dividing it by x plus 2, remember, set this equal to 0 and solve for x. That's what we're doing here. And the coefficients go here. We bring down that first term, multiply, stack it up, add, get an answer, repeat, multiply, stack that answer up here, add, and then we're going to interpret that as we start with the next lower power, x squared. We'll take that answer and put that 2 in front of the x squared, minus 7, just keep descending, x plus 18 to the 0 power. When you get to the 0 power, you have your constant, and the rest will be your remainder. Just kind of repeating that until it sinks in. And I could go faster if my pen didn't disappear. All right, so let's try another one. We're going to use synthetic division to divide 5x squared. So let me bring down that 5 here. And then the negative 3, we're just going to take the coefficients. And then negative 36 is the constant. Let's see if we're missing any terms, because we do need to fill in. No, we don't need to fill in zeros with synthetic division. So I don't have to worry about that. So we're going to take this 5, negative 3, and negative 36, and we're going to put an upside down division symbol, leave room for another row of numbers, and then we're going to take the x minus 3 and solve for x. So x is equal to positive 3, and we'll put a positive 3 out here. Crazy positive 3. Bring down the first term, and then start your process of multiplying. 3 times 5 is 15, and then adding. Negative 3 plus positive 15 is positive 12. Repeat that step. Multiply 12 times 3 and get positive 36. And when you add that, you get 0. Okay, so how do we interpret our answer? Our answer is going to be 5x, because we start with 1 less than the power that we have here in our dividend. All right, so we had x squared, so we subtract 1 from 2 and we get x to the first power, and then just keep going down. And then we have a positive 12, x to the 0. That's going to be our constant. So that's when we know where to stop. And then we have a remainder of 0. We don't write remainder of 0. So our answer is just 5x plus 12. Okay. All right, so that's all that we have today. Let's just kind of review. Do you know how to use the remainder theorem to proceed to the correct answer? So sometimes the quizzes, you know how to do it, but we don't know how to enter the answer. So let's look at what this is asking. All right, so we're trying to divide negative 4x to the 37th, and then it jumps down to 12x to the 15th power, and then way down to negative 2x to the first power, and then our constant. Okay, we're dividing it by this, so we've got to solve for x, set that equal to 0, subtract 1 from both sides, x is equal to negative 1. Okay, so Kim evaluates the numerator, that's the top, of the rational expression when, and I'm just going over this because you'll see a question like this. What's it asking? When what? When x equals negative 1. We take that denominator, which is our divisor, and we set it equal to 0, and we determine what to use for x. Okay, and then we plug that in. We put a -1 in here everywhere there's an x. So this is going to be an odd power. That's going to leave us with a -1 times a -4 is a +4. And then we have another odd power. -1 to the 15th power is -1 times a +12 is -12. And then we have just -1 times -2. Don't forget that's negative, is a +2 plus 14. And if we add that together, I've got, let's see, 4 minus 12 is 8, 9, 10, 11, 12, -8 plus 2 is -6 plus 4 is -2. And I don't think I did that right because I rushed through because I don't see that as an answer. So the remainder of the division is, maybe I didn't put the right answer. Let me go back and try that again. So we know -1 to the 37th power is -1 times -4 is a +4. This is going to give us a negative times a positive, -12. This is going to give us a negative times a negative is a positive. I see my mistake. This is 14. Is that right? So that's a +2 plus 14. So let me try that again. See how easy it is when you're rushing to make mistakes? All right, so 4 minus 12 plus 2 plus 14 is equal to 8. So she concludes, I'm just struggling with trying to find my pen. So she concludes the remainder of the division is 8. That's how you answer that question. And again, go slow because it's so easy to mess up, especially with negatives. All right, what does the remainder theorem conclude given that f of x divided by x plus 6 has a remainder of 14? So it's just asking you how to word this. What have we been doing? Focusing on the vocabulary, speaking it, talking it out, speaking in what we know how to do numerically. So if we solve x plus 6, we set that equal to 0 and solve for x. X is equal to -6. So f, we take that when we plug it into the function, take that and put it back into the function, f of x. So f of -6 with a remainder of, if we plug that in and we come up with 14, that's our remainder, meaning x plus 6 is not a factor or not a solution because we would have a remainder. I hope that's coming together, making some sense for you. All right, so for this, this is the in-class version. Let me find you the code for the, hold on, for the outside of class. We're going to go to join.nearpod.com, and you need to work through this activity as your exit ticket. Join. All right, remember to use, if you're doing this outside of class, download the slide deck that I have and look in the notes to find the code. Now, the code that we're going to use outside of class is N as in Nancy, F as in Frank, 9, the number 9, the number 7, the number 3, and then join. Again, hopefully you're using your device that you got from K-12 with Office installed. If you're using another device, install Office and make sure you're logged in. Then click on Sign In with Office 365. Not with Google, not with Clever, not that I know of yet. I don't think that's working, or not with ClassLink. I don't know if that's working. The only thing I know is Office 365 will guarantee that you're not using someone's slot and that you are logging in as yourself. And you can verify that with the name. If it's not you and you're struggling with that, you need to let me know who you are so I can get your grade in. But don't avoid that step.
Your Grace, we have the prisoner.
Bring him forth.
He's accused of holding classes in the forest, Your Grace. He's been teaching the peasants.
Teaching them? Teaching them what?
I'm teaching them math, Your Grace, long division.
Teaching them black magic and sorcery?
No, Your Grace, it's...
Long division? Throw him in the pit of doom.
You do know what long division is, right, Your Grace?
Of course I know. I'm the king. But explain it to me anyway.
I'll go warm up the pit, Your Grace.
When dealing with polynomials and basic operations, people seem okay with adding and subtracting and even multiplication. But when it comes to dividing, lots of folks go into hiding, 'cause dividing can be difficult, especially with binomials. I know it's easy to get overwhelmed. You ask yourself, just where should I begin? Think back to younger days of yore when fourth grade teachers would implore you to practice long division again and again. If you could follow the process with its 4 little steps, you'd be just fine. Divide, multiply, subtract and then bring down. Do it all over till you can't bring down anymore. Divide, multiply, subtract and then bring down. If you can't bring down, bring it on. If there's something left over, it's called a remainder. You can write it with the letter R, but there's a much better way, much better by far. Make a fraction of the leftover part over the number being divided by. Here to polynomials, let's give it a try. Divide, multiply, subtract and then bring down. Do it all over till you can't bring down anymore. Divide, multiply, subtract and then bring down. If you can't bring down, bring it on. If that polynomial you're dividing into skills of variable power put zero term in. If that polynomial you're dividing into skills of variable power put zero term in. Be careful when subtracting. Subtract the whole binomial, not just the first term. No, subtract the whole binomial. Be careful when subtracting. Subtract the whole binomial, not just the first term. No, subtract the whole binomial. Multiply, subtract and then bring down. Do it all over till you can't bring down anymore. Divide, multiply, subtract and then bring down. If you can't bring down, bring it on. If you can follow the process with its 4 little steps, then you can long divide.
Grace, we've warmed up the pit.
That's long division, and if you like, you can join us in the forest every Friday night. Divide, multiply, subtract, and bring it down. Divide, multiply, subtract, and bring it down. That's how we do long division now. Divide, multiply, subtract, and bring it down.
I have learned a lot about long division, but throw him in the pit of doom anyway!
Complete the quiz at the end, and that'll be your exit ticket.